This is the AP Stats 7.3 homework video on sampling distributions of sample means. So recall what a sampling distribution is, that it's every possible sample of the same size. And if you think about that, the real idea behind it is that if we have every possible sample, we take chance variation, random chance, out of the picture. Because for every time that we have a sample mean that is below the mean, we also have one that's above the mean. Since it's every possible combination, the average of all those samples would be the true average. So it's one way that we look at sampling in order to get a better picture of what we should really expect when trying to estimate our parameter or whatever it is we're trying to measure in the population. So again, in reality, we never have a true sampling distribution. So we usually just take enough samples to try to approximate it. And we try to use a big enough sample size to get a good approximation of it, where we can be reasonably sure that we have a good idea of the true parameter that we're trying to measure. Now, the first difference you want to look at when looking at problems and sampling distributions and moving forward is, am I dealing with a sample mean, meaning the average, or am I dealing with a proportion? Many of you have more experience with percents. So remember, 90% would be 0.9, 8.5%, 0.085. So start thinking, do I have part of a whole here? Like in class where we did what proportion of the pennies were from the 2000s. So that was like 2 out of 5, 0.4 would be your proportion. Or in class upcoming, we're going to look at the average age of the pennies, where you averaged out. So if I had 3 pennies that were ages 3 years old, 5 years old, and 7 years old, I'd add those up. We'd get 15 divided by 3 is 5. So my average age would be 5 years old. That's a sample mean. Remember, everything with an accent above it is the sample. So x bar is our sample mean. Mu will be our parameter, the true mean that we're looking for. If all the p's are for proportion, so p hat is my sample proportion, whereas p is my parameter. This video we're looking at sample means. So you want to be thinking about x bar as the sample mean. So there's a lot of similarities in terms of sample size and what happens, but there are some differences. For example, if you think about the normal condition, and the 3 conditions are something you should focus on, as we're going to be building towards more questions involving confidence intervals, and those 3 conditions will be there, and involving significance tests. So for example, the normal condition where we had NP, the sample size times the proportion, we don't have a proportion anymore. That had to be greater than or equal to 10 for sample proportions. Now we have a mean, so that condition is going to have to be different. However, the random condition is the same. We need a simple random sample. We need randomization to have an unbiased estimator. And then we know the mean of our sampling distribution equals the true value. And we need to sample less than 10% of the population if we're sampling without replacement, so that our calculations in terms of the probability of selecting an individual remains close to the same. So those two conditions remain the same, whereas our normal condition changes. So for the sampling distribution of x bar, it says how that statistic, my sample mean x bar, varies in all possible samples of the same size. So unless we have all possible samples, it's not the sampling distribution. If I had 500 samples, then what I'm trying to do is approximate the sampling distribution. So keep that in mind. It's an unbiased estimator. When we say that, we're saying that we're getting a true picture of what's really going on. We don't have a convenience sample. We don't have voluntary response that's leading us to an overestimate or an underestimate of the true parameter on a consistent basis. So our estimator overall in the long run tends to give us the true value. That doesn't mean every time we take a sample we'll get the same value. We could be flipping a coin again, and one time we flip it 50 times, we get 30 heads. Another time we get 22. Another time we get 26. In the end, if we did every possible combination, the average of all those would be 25, the true probability, 25 out of 50. Taking a sample. So, for example, I ask 90 students how many hours of sleep they got from our school here, 90 students at our school, and one sample would be the average of all the hours of sleep they got. That's one x bar. That'd be my first sample, and then that would pop down here, and then I would take a second sample. The average for that second sample would go down here. Now, as I add more and more samples, I start to get a distribution that approximates the sampling distribution. because I'm starting to have more and more averages that reflect different combinations of students, where I'm finding the average hours of sleep per night. So once I had enough, like let's say I took that sample of 90 and let's say I did it 50 times, then I would start to be approximating the sampling distribution and the average of all those averages. So that gets a little complex. Remember, each one of these is an average. When I graph them all and I find the average of those, it's an average of averages. That's another way to account for chance variation, but that average would tend to be closer to the true value. Since by chance we might be a little bit above, by chance a little below, but a large sample size and several samples help me account for that. So the average of my sampling distribution, if I had all those possible samples, it becomes my sampling distribution, and the average would equal the true parameter, meaning the true average number of hours of sleep for all students at Sacred Heart. So realize that each of these in our distribution here is one sample and the average from that sample. And again, the height tells me the frequency, meaning my mode is right here. Conditions that you need to be checking every time we do calculations. I've given these to you on the first quiz. When we get to our test, I'm just going to have blank lines. You need to know that you need to check the random, the center condition. Again, that's called random or center because if we have randomization, then we know the center or the average of our sampling distribution equals the true average, which is the measure of center. And that is what this symbol means. The average of my sampling distribution equals the true value, the true parameter that we want to estimate. Again, that's our goal with all this. We're trying to find out something true about the population without actually having to ask everybody. The normal condition is shape, since a normal distribution would describe shape. So there's two ways it can be satisfied for a sample mean. If we're sampling from a population that is approximately normal, then it's met and you don't have to go on. If we're sampling from a distribution that's skewed, then we need a sample size of at least 30, and that's the central limit theorem. We need a sample size of at least 30 so that we know that the sampling distribution is approximately normal. So either one of those could be met. The population is approximately normal, or our sample size is at least 30. And remember, we write normal by this capital N, and then the mean and standard deviation in the state portion of your problem that should be included. The independent condition is our third condition, which describes spread, because we need this condition to be met in order to use the formula for standard deviation, which is a measure of spread. So we need to make sure we don't sample more than 10% of the population when sampling without replacement. That means little n, the size of my sample, has to be less than or equal to 1/10 of big N, the size of the population. Another way to show this that some students find easier is take your sample size. If it's 90, multiply it by 10. The population would then have to be at least 900 for us to have sampled 90. So those are our three conditions. Random and independent are similar as before. The formula for standard deviation is different. We'll look at that in just a second. However, the condition is the same. The normal condition is different because we don't have a proportion here. So this is one to review because students get confused between n is greater than or equal to 30. Remember, that is just for sample means, not sample proportions. Depending condition is met, we can use this formula for standard deviation. The population standard deviation divided by the square root of the sample size. So if I had a sample size of 16 and my population standard deviation was 10, I'd have 10 divided by root 16. The square root of 16 is 4. 10 divided by 4 is 2.5. That would be the standard deviation of my sampling distribution. So remember that as n goes up, my standard deviation of my sampling distribution would go down. That's an inverse relationship. With bigger sample sizes, we'll tend to have less spread because the sample mean is more likely to be close to the true value. It's less likely to vary. Just like flipping a coin 50 times, we're less likely to have 50 heads than flipping a coin 5 times. We could get all 5 heads. It's more likely. And 5 heads is plausible when we're just flipping 5 times when n equals 5, but it's no longer plausible when n equals 50. This can be used if that independent condition is met, and then the central limit theorem is the normal condition here. If population is normal, we're good. If not, then n has to be greater than or equal to 30. Good time to pause. Go ahead and review the summary for 7.3 in your book. Focus on those conditions. Look at some example problems to get you set up for success on our quiz. Here's our multiple choice about the 3 conditions and which one is different from sampler proportions. So pause now, answer the multiple choice, and here's your free response. We find that the SHC student population standard deviation for the number of hours of sleep per night is 1.5 hours, 1.5. We conduct an SRS and gather the amount of hours slept per night for 100 students. What is the standard deviation for the sampling distribution when n equals 100? And show the work there in the free response.